In this video, I will give you an explanation of the basics of X-ray photon correlation spectroscopy, or XPCS for short, and how we can use this technique to get information about the structural kinematics and dynamics of molecular systems on time and length scales that are typically on an atomic scale. Time scales from hours to picoseconds are accessible. For example, slow processes like protein aggregation typically occur in the range of minutes to hours, conformational transitions in seconds to microseconds, and molecular tumbling in the time frame of multiple nanoseconds. In addition, length scales from micrometer down to nanometer can be measured. This information is provided by analyzing the fluctuations of the nanostructures present in your sample. All living beings are made of trillions of living cells, which all perform many different tasks. So let's have a closer look at the dog over there. We can see that its cells consist of a variety of different macromolecules such as amino acids, proteins, sugars and salts in a very narrow space surrounded by water. Diffusion within the cell can strongly influence the reactions between these macromolecules and thus the functionality of the cell itself. Understanding the dynamics of these crowded environments is therefore of utmost importance. So, let's have a look at the diffusive behavior of the macromolecules. Imagine a protein molecule surrounded by water. From time to time, the water molecules collide with the protein, resulting in random fluctuations of the protein. This type of motion is called Brownian motion and depends on the size of the protein. Smaller proteins diffuse faster, while larger proteins diffuse much slower. This behavior can be described by the Stokes-Einstein relationship, in which the diffusion coefficient d is related to the sample viscosity eta and the particle radius r.